Previously, we talked about relative maximum and relative minimum. So on the side here, let me just remind you guys of what a relative maximum looks like. So relative maximum, if let's say this is your graph right here, then a relative maximum is going to be this point. It says relative because around its immediate neighbors, this is the highest point, also thought of as a turning point. Same thing for a relative minimum. If we have a function that looks like this, then this will be a relative minimum because around its neighbors, it's the lowest point. Now, the word absolute, it means that in whatever specified interval we're looking at, it is the absolute, not relative, absolute. So it's the tallest, the highest, or the lowest point in that interval. Okay, so once again, relative, it just means relative to its immediate neighbors. It's the highest or lowest. But absolute means in whatever interval we're specified, it's the highest or lowest point in that interval. Now let's take a look at a graph. So let's say we have this graph on the interval of -1, 2. Then when we look at the word absolute, it means that it has to be the highest or lowest point in that interval. So this point here is the absolute maximum because in the interval from x equals -1 to x equals +2, this is the highest point. The lowest point is going to be this one because from the interval of x equals -1 to x equals +2, this is the lowest y value. Another example. In this case, our absolute maximum in this interval occurs here, and our absolute minimum occurs there. In this interval, this is going to be our absolute minimum. That'll be our absolute maximum, the highest or lowest point within a given interval. Now, if you notice a pattern that the absolute maximum or minimum either happens at a point where the tangent line has a slope of 0, in other words, a critical point, or it happens at an endpoint. Like here, the absolute maximum was an endpoint. Over here, it was the critical number. Here, the absolute maximum was a critical number, and the absolute minimum was an endpoint. Here, both the absolute minimum and the absolute maximum, these are both endpoints of the interval. So when you think about an absolute maximum or absolute minimum, it basically means that the absolute maximum minimum can occur at either the endpoints or at a critical point. So when we want to find the absolute maximum or absolute minimum, we need to evaluate the endpoints and the critical points to see where we have the highest and lowest point within a given interval. So here's an example. So here's the theorem. Suppose that f is a continuous function defined over a closed interval. To find the absolute maximum or minimum, first find f prime of x and determine all the critical values. Remember, critical values are where f prime is equal to 0 or does not exist. Then we list the values and the endpoints of each interval. So remember, the absolute maximum or minimum either occurs at the endpoint or at a critical point. So we list all the endpoints and we list all the critical points from step B. Then we want to evaluate the y values for each of the critical points and the endpoints. And the largest of these is the absolute maximum, the smallest is the absolute minimum. Here's an example. Consider the function 2x squared minus 6x plus 8. Find all critical values and list endpoints. So remember, critical values occur when the derivative of this either equals to 0 or it's undefined. So first, let's find f prime of x. 2 times 2 is 4. So we get 4x. This is like an invisible 1 over here. 1 times 6 is 6. And nowhere is this going to be undefined because we're not dividing by a variable. But we could set it equal to 0. So we would add 6. We would get 4x equals to 6. Then we would divide by 4. And we would get x equals to 3 over 2, which is 1.5. Let's use decimals. Okay, so this is a critical point or a critical value. Now we want to list all the endpoints. So our interval starts at 0 and ends at 10. So the endpoints are going to be x equals to 0 and x equals to 10. So that's our critical point, and these are our endpoints. Now, this theorem says that the absolute maximum or minimum can occur at the endpoints or at a critical point. So these are our only possibilities for us to get an absolute maximum or absolute minimum. So let's plug all these in. So remember, you can use Desmos, put in f of x equals 2x squared minus 6x plus 8, and then put f of 1.5. F of 1.5, this will give you 3.5. Then put f of 0. F of 0 will give you 8. Then put f of 10. F of 10 will give you 148. Now, out of these, we want to find out the absolute minimum, which is the smallest point on this interval. So this interval contains 0 and 10. Those are our endpoints, and the critical point. Those are the only places where the absolute maximum or absolute minimum can occur. So the absolute minimum is going to be this point, which is 3.5, and it occurs at x equals to 1.5. The absolute maximum is 148, and it occurs at x equals to positive 10. Let's verify this by looking at the graph and making sure that what we are saying is actually correct. So let me pull up Desmos real quick. And let's graph our function. Our function was f of x equals to 2x to the second power minus 6x plus 8, but then we have a restricted interval, which is from 0 less than or equal to x less than or equal to 10. So this is what our graph looks like. We want to find the absolute minimum and maximum. So I can tell that the lowest point is going to be this one, where x equals to 1.5 and y equals to 3.5. And that's exactly what we said. We said our absolute minimum is y equals 3.5 occurs at x equals 1.5. Now we have to zoom out a little bit for the absolute maximum. It's all the way up there. On this interval, the highest point is going to be this point, which is 148, that's the y value, and it occurs at x equals 10. Okay, so the function starts here, the function ends there, that's the absolute minimum, and that up there is the absolute maximum. Okay, let's take a look at the next example. All right, consider the function f of x equals 2x cubed plus 21x squared minus 108 x plus 3 on the interval between -9 and +3. So find the absolute minimum and absolute maximum. Now, where could the absolute maximum or minimum occur? It could occur either at a critical point. This is where f prime of x is equal to 0 or it's undefined, or it can occur at an endpoint. So we know what the endpoints are. The endpoints are -9 and 3. That part's easy. We got to find our critical points. So for our critical points, we need to find f prime of x, which is going to be 6x to the second power plus 42x minus 108. And we want to figure out where is this undefined. So it's not undefined anywhere because we're not dividing by a variable, but we could set it equal to 0. And then I'm going to simplify this by dividing by 6. So I'm going to get x squared plus 7x minus 18 is equal to 0. If I factor this, I get x plus 9 times x minus 2 is equal to 0, which means x equals to -9 or x equals to +2. These are my critical points. My endpoints are x equals -9, which is actually a critical point as well, and x equals to +3. So I want to find the corresponding y values. So I'm going to go back to the original function, and I'm going to plug in f of -9. I'm going to plug in f of 2, and I'm going to plug in f of 3. So if I plug in -9, I get a really big number. I get 1,218. If I plug in f of 2, I get a small number, -113. If I plug in f of 3, I get -78. So the absolute minimum is the smallest value on the interval, which is negative 113, and it occurs at x equals to 2. My absolute maximum is going to be y equals to 1218, and it occurs at x equals to negative 9. Right? Last example. We got a function f of x equals to 6x plus 24x to the negative first. Now this time is a little bit different because we have 0 less than x less than infinity. So we have no upper bound. On the right side, the function is going to go to infinity. So let's see what happens. First off, we know that our absolute minimum or absolute maximum can occur at one of these points. It can either occur at a critical point or it can occur at an endpoint. So let's find the critical points. For critical points, we need f prime of x. So this is going to be 6. Negative 1 times 24 is negative 24. X to the negative second. We don't want negative exponents, so f prime of x is going to be 6 minus 24 over x to the second power. Now, could this be undefined? Yes, it can be undefined if x equals to 0. That makes this function f of x undefined. Therefore, x equals to 0, that's a critical point. We also have a critical point when this function, 6 minus 24 over x to the second power, equals to 0. So to solve this, I'm going to just add the 24 over x squared to the other side because I want the numbers on one side, variables on the other side. So I get 6 equals to 24 over x squared, but I don't want the x squared on the denominator, so I'm going to multiply it to both sides. This gives me 6x squared equals to 24. I divide everything by 6. I get x squared equals to 4. And if I square root both sides, I get x equals to plus or minus 2. So these are also my critical points. So my critical points are going to be 0, negative 2, and positive 2. And then on the right, the function is approaching infinity. So we gotta figure out what that is as well. So we want to figure out what happens to our function when x approaches infinity. So let's plug in all these into the original function. F of 0, this is actually undefined because the original function is x to the negative first, which is x on the denominator. If you divide by 0, it's undefined. If we plug in x equals to negative 2, we get negative 24. And if you get x equals 2, we get positive 24. Now, as x approaches infinity, let's think about this. 6 times infinity is going to be infinity. So as x approaches infinity, f of x is going to also approach infinity because 6 times infinity is going to be infinity. So our y value is also going to approach infinity. Basically what this means, since the function is approaching infinity, it's going up, 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 that means there is no absolute max. Absolute max only occurs if we have a definite maximum or highest value within an interval, but because this function goes to infinity, we don't have an absolute maximum. Our absolute minimum is going to be this value, negative 24, and it occurs at x equals to negative 2. So in this case, we only have an absolute minimum, which is negative 24, and it's going to occur at x equals to negative 2. And I'm kind of shocked that we finished an entire section in only one video.